Artificial intelligence does not run inside a laptop. It runs inside machines so powerful they resemble digital power plants. Rows of processors, miles of cables, cooling systems, electricity at industrial scale. And at the center of many of the world's most advanced AI systems are NVIDIA's AI supercomputers. Artificial intelligence often feels invisible. You type a question, you receive an answer. You generate an image, you summarize a document, you run a model. From the outside, it feels like intelligence exists inside software. But that is only the surface. Underneath modern artificial intelligence lies a physical system built at extraordinary scale. A system of processors, networking, data movement, cooling, and power. And in many of the most advanced AI environments on Earth, that system is built around NVIDIA hardware. This is the real architecture of the AI age. Not just algorithms, machines, massive machines. To understand why NVIDIA's AI supercomputers matter, we first need to understand what modern AI actually requires. Large AI systems are trained through repeated mathematical computation. Models process huge datasets. They analyze patterns. They adjust internal parameters. They repeat the process again and again. This workload is not small. The largest modern AI systems require enormous compute. And compute at this scale is not something a normal machine can deliver. That is why AI moved into data centers. And inside those data centers, it moved toward GPU clusters. Graphics processing units were originally designed for visual rendering, but their architecture turned out to be extremely effective for neural networks. A CPU is flexible and sequential. A GPU is massively parallel. That difference matters. Neural networks depend on repeated matrix operations across huge quantities of data. GPUs can handle these workloads far more efficiently than traditional processors. As AI systems grew, that advantage became decisive. And as that advantage became decisive, NVIDIA became one of the most important companies in modern computing. But a single GPU is not what powers the most advanced AI systems. The real story begins when thousands of GPUs are connected together. That is where AI supercomputers emerge. An AI supercomputer is not simply one large box. It is an integrated compute environment. Multiple nodes, multiple servers, large numbers of GPUs, high-speed interconnects, storage systems, power distribution infrastructure, thermal management systems, and software layers coordinating the whole machine. These systems are built to handle workloads far beyond ordinary enterprise computing. Training a frontier AI model requires huge volumes of data moving rapidly between processors. The system must support high bandwidth, low latency, and high reliability at all times. If communication between processors is too slow, the entire training process becomes inefficient. That is why NVIDIA's AI systems are not only about GPUs. They are also about the networking and system design around those GPUs. This is one reason NVIDIA's position became so strong. The company did not just build chips. It built a compute ecosystem. The GPU matters, but the interconnect matters too. The software stack matters. The data movement matters. The orchestration layer matters. A true AI supercomputer is an infrastructure system, not just a processor purchase. This is where many people misunderstand the AI boom. They imagine the future of AI as better models alone. But better models require better machines. And better machines are not defined only by raw chip speed. They are defined by how effectively thousands of chips can operate together as one computational system. That is the purpose of AI supercomputing: scale, coordination, throughput, and sustained compute density. Inside these environments, GPUs are arranged in clusters that can process enormous workloads simultaneously. The servers are connected through high-performance networking fabrics. Storage systems feed data at speed. Cooling systems remove enormous heat. Power systems deliver stable electricity to dense racks of hardware. Everything is engineered for continuous high-performance operation. This makes NVIDIA's AI supercomputers more like industrial infrastructure than consumer technology. They are not gadgets. They are digital production facilities. Production facilities for intelligence. That is what makes them so important. The modern AI economy depends on the ability to train and serve increasingly powerful models. And that depends on machines capable of handling unprecedented computational demand. This is where NVIDIA's systems became central. As demand for AI accelerated, companies needed more than single servers. They needed clusters, then larger clusters, then facilities capable of supporting entire AI environments. Cloud providers, research labs, and major technology firms all began investing in NVIDIA-based compute infrastructure. That created a new class of machine, the AI supercomputer. These systems matter for three major reasons. First, they compress time. A model that might take far too long to train on conventional infrastructure can be trained much faster on a properly scaled GPU cluster. Second, they expand ambition. Bigger compute makes larger model architectures practical. Third, they concentrate power. The organizations with access to the largest and best-run AI compute systems gain a major advantage. That third point matters most. Because AI is no longer only a software competition, it is a compute competition. And compute competition favors infrastructure scale. The firms with the strongest supercomputing environments can move faster, test more, train larger, and deploy more aggressively. This is one reason NVIDIA became so strategically important. It sits near the center of that compute race. But what exactly makes an NVIDIA AI supercomputer different from ordinary infrastructure? One answer is density. These systems are designed to push far more computational performance into each rack, node, and cluster than standard enterprise systems. Another answer is interconnection. AI workloads depend on extremely fast movement of data between processors. A third answer is optimization. The hardware, networking, and software stack are designed around AI workloads, not just generic IT needs. And then there is scale. These are not isolated machines. They are environments. Environments designed to support the industrialization of machine learning. That industrialization changes everything. Once intelligence becomes infrastructure, the economics shift. The limiting factor is not only talent, it is also hardware access, energy access, data center access, supply chain access. This is where NVIDIA's AI systems become part of something larger than computing. They become part of strategic power. The organizations building frontier AI systems need these machines. The organizations controlling these machines gain leverage. And the countries hosting this infrastructure gain relevance in the global technology order. That is why AI supercomputers are no longer niche engineering systems. They are now part of the geopolitical and economic architecture of the modern world. There is also a thermal reality here. AI supercomputers generate enormous heat. That means cooling is not secondary. It is central. As compute density rises, heat density rises. Air cooling can only go so far. More advanced deployments increasingly rely on more sophisticated thermal systems. This includes direct liquid cooling and other high-efficiency methods for removing heat from dense compute environments. This matters because raw compute without thermal stability is useless. A supercomputer must sustain performance. That means stable power, stable temperature, stable networking, and stable orchestration. This is why the term AI supercomputer should be taken literally. These are not just servers with better marketing. They are highly engineered compute systems built for one of the most demanding categories of workload in modern history. And that workload is becoming more important every year. As AI products spread into search, software, media, customer support, research, defense, logistics, and education, the demand for powerful infrastructure rises with them. That means NVIDIA's AI systems are not simply serving a few labs. They are helping define the backbone of a new digital economy. This also explains why capital investment in AI infrastructure has grown so quickly. Firms understand that if they want a meaningful role in advanced AI, they need access to serious compute. That can mean building infrastructure, renting infrastructure, partnering with cloud providers, or competing for limited hardware availability. But the logic remains the same. Advanced AI requires advanced machines, and advanced machines require system-level engineering. NVIDIA's role in this system is larger than chip supply. It is platform supply. The company's influence comes from the fact that its hardware is tied to an ecosystem of tools, deployment logic, interconnect design, and performance expectations that large AI operators now depend on. This creates inertia. Once a company builds around a hardware ecosystem, changing that ecosystem is not simple. So control compounds. A chip advantage becomes a platform advantage. A platform advantage becomes a deployment advantage. A deployment advantage becomes a market advantage. This is how infrastructure leadership turns into broader technological power. There is also a symbolic meaning to NVIDIA's AI supercomputers. They show us what artificial intelligence really is becoming. Not just software that appears on screens, but intelligence produced through industrial-scale computation. That is the defining reality. Modern AI is not floating in the cloud. It is running inside highly specialized, energy-intensive, physically engineered systems. Those systems consume power. They consume capital. They consume space. They require supply chains. They require maintenance. They require cooling. They require strategy. So when people say AI will change the world, the hidden truth is that machines like these are part of how that world change happens. This is why NVIDIA's AI supercomputers matter more than most people realize. They are not background infrastructure. They are active engines of the current AI era. Without them, many of the most ambitious AI projects on Earth would slow down dramatically. Without them, the current pace of AI development would be far harder to sustain. Without them, modern artificial intelligence would still exist, but not at this scale, not at this speed, and not with this level of global impact. That is the final point. The future of AI will not be shaped only by better software models. It will also be shaped by who can build, deploy, and operate the machines powerful enough to support them. And right now, many of those machines are NVIDIA's. Not hidden in theory, not hidden in code, but running in real places, inside real data centers, powering the systems that are reshaping the world.